Hi, everybody. So I've been making maps for about 20 years, but this is my first NACIS, and it's wonderful. Glad to be here. So I work with wildlife data. I work for National Audubon Society, and so I've spent a lot of time thinking about this question of what are your gradient maps? What are they really saying about your data? I'm frequently using wildlife data to identify priority areas for conservation and to send messages to decision makers, and so it's really an important consideration in my work. So today I'm going to use two data sets to illustrate this. So the prothonotary warbler, this is a light level geolocation data set with about 3,000 relocations. And the osprey, which is a GPS satellite tracking data set with over 6 million locations gathered over 20 years. And so you'll notice that these two different size data sets, they have a very similar distribution, and this is common in the wildlife data I work with, where there's a high frequency of individual sightings or small groups and a low frequency of large groups. So I'm going to talk about 6 different classifiers, and processing for the first 5 is the same, and it's a breeze. You're aggregating points from multiple studies, you're standardizing those in terms of projections and their attributes, and taking out outliers. And then in this I've used the Reconstruct Tracks tool in the Geoanalytics toolbox in ArcPro, and then do a few more processing steps to then put it into the summarize within tool in that same tool set. And then eventually you have this hexagon gradient map that's representing the number of individuals that passed through each one of those hexagons. For the 6th classifier, it's a little bit of a different process. So for isopleth, which is my favorite of the 6, you can't actually get that in ArcPro or in any software package that I'm aware of. You have to add in a few more steps. So you have to convert your tracks to a line density raster, import that raster into R, at least that's how I do it. Then I have a little isopleth script that I've written. Then I need to convert my output into vector polygons and bring that back into ArcPro before I can get on with things and put it on a map. So I'll talk through 6 of these, and the first one is natural breaks. So this is the default if you're using ArcPro. And what it's doing is grouping similar values that maximize the difference between classes. And because it's really specific to your data set and how data are grouped in your data set, it's not useful for comparing across maps because your classes would be different for every map. So it also doesn't seem terribly useful for wildlife data. It's one that I never end up using, even though it's the first one that always shows up. So equal interval is very straightforward. Every class is the same width. And this is really good for things like percentages and temperatures, linear data. But for my data, you can see that it's really undervaluing the low values and the mid values in the landscape. Then there's geometric interval. So this is a good one. It is one that I frequently use because that isopleth isn't an easy option that I can just grab quickly. And this is a pretty good one. So it's minimizing the sum of squares of the number of elements in each class. And it's designed to accommodate continuous data by compromising basically between the equal interval, the natural breaks, and the quantile. And so a lot of times I have a sense of what the underlying pattern is in a data set and kind of how I want it to look to get the point across. And this one usually hits the mark pretty well. Then we have standard deviation. This is a good one too because it's classifying your data to represent how far above or below the mean your data values are. And so that's meaningful, especially in context of wildlife populations. And so that's being calculated automatically for you, and then you're mapping it in intervals of 1 or a half or a quarter standard deviation and so on. Quantile is the one I really don't like because it looks really good, but I don't feel like it really means anything. It gets used a ton, and it does actually, cartographically, it kind of gets it right. But what it's doing, the math doesn't make a lot of sense in this case because it's putting the same number of unique data values into each class. And you have to really ask yourself, what does that mean? Why is that important for wildlife conservation or any other type of data set you might be throwing into a quantile? What are you really telling your map reader when they're looking at that? So it's good for linear data. It especially doesn't make sense when you have continuous data with lots of decimal places because you rarely would have a repeated value, so it's kind of all unique values. And so I just really try to stay away from this one. So that brings me to the isopleth. And again, this is by far my favorite. And the reason is because it's measuring something that's it's very relevant for what I care about. It's telling me what % of my population is present in each class. So what it's doing is it's taking the total of all of the cells in the data set and summing them and then splitting that into equal sum classes. So this is in 10% bands, and so the first band is where 10% of my population is located, and the second band is where 20% of my population is located. It just makes a ton of sense, and it's actually really easy to calculate. And it oftentimes just is the one that gets it right. So also the 50% isopleth is commonly used by wildlife biologists as a delineation of core areas for a population. And 50% isn't a magic number in terms of conservation biology, but it at least gives us all a currency to work in and make comparisons. So now we can just take a look at all of those side by side and see the differences and the similarities. You can see how Quantile looks really good, but again, I'm not quite so sure exactly what it means. So geometric interval and standard deviation would be my second and third choices here. So I went ahead and I did this again with the Osprey data set, those 6 million points I mentioned. And it's really overemphasizing in most of these examples that eastern migration corridor. And the reason I say that is because I know something more about this data set, which is where the trapping locations are. And most of those birds were tagged in the east. But osprey live all across the country. You've probably seen one wherever you live. And so by using something that's emphasizing the east over everything else, including the isopleth in this case, you're kind of you're leading people toward an inherent bias in that data set that I would rather not emphasize so much. So in this case, the geometric interval is the one that I would actually show people because I feel like it's doing a better job at representing osprey distribution and not just the bias built into the data set. So to summarize, don't accept the defaults. Quantile looks good cartographically, but in my opinion, it doesn't have much meaning for wildlife data. The geometric interval and standard deviation usually do a good job with skewed wildlife data and mean something mathematically with that data set. And isopleth, I think, is the very best. It's not always the best, but it's not an easily available classifier at my fingertips when I'm trying to make a quick map. And then just to keep in mind that most people will only have access to these data through the map that you made. So it's important to make responsible choices in how you're showing it. That's it. Thank you.